Oh, hey, come on in. We'll talk about pocket knives.
My project today is an Ulster Barlow knife. Ulster is the name of the manufacturer. Barlow refers to the shape or style of the knife. Here you see a close-up of the bolster with the name engraved on it, and this tang stamp indicates that this knife was made sometime in the 1950s. This knife was a gift to me. It was once of very good quality and has obviously been carried and used for many years, but the blades now have no snap. The spring tension that holds the blades in position should cause a snap sound whenever the blades open or close, but these blades are loose and have little or no tension. This can be caused by many things: dirt, rust, a lack of oil, or wear on the parts inside of the knife. In this case, I've already cleaned and oiled the knife and it did not help at all, so now we'll disassemble the knife to further diagnose these problems. Now, the best way that I've found to remove a pivot pin, there's a couple of different methods. This is one that I've used many times, though, is to take the Dremel tool and I have a small ball burr on it. These are fairly inexpensive. You can get the ones that are carbide steel. You can get those that are regular high-speed steel, and you can get them with diamond. What I'm going to do is use this to carve a dimple in the center of that pin. Okay, after I've drilled the head of the pin off, or ground it off with that, you see the head of that pin is completely gone. I'll lock the knife in my vise, use a pin punch, I'll try to move my hands out of the way as you can see, and oh, there it goes, drove the pin right out of the knife. You want to do that carefully, especially with bone handles. It's easy to chip or crack those. Now, with that out of the way, we still have the pin holding the springs here, but on this knife, the springs will now swing right out. Let's see if I can get a hold of that one. There we go. Now then, so what we'll do is we'll clean up those springs some and study them and see what we've got. You see there's a small dimple there on the end of that spring, and a small one on the end of that spring. So if we can get the camera to focus on it properly, I don't know if we can ever see it, but occasionally catch a glint of light off those. In person, you can see them very well. Now, the other problem with this is with the tangs of the blade itself. Let me grab something to point with. There. I'm going to try to hold this up to the light so you can see the tangs of the blade right inside here and right inside here. And you see this one sits much lower than that one. If I can get the angle just right, you can see that it is sitting lower. Originally, those two would have been the same height. It means they've worn. The small blade is worn down further than the big blade. There is a way to fix that. We'll go into that next. But what I'll have to do is first drive this spring, or this pin out, this pin that goes through the both blades. We'll do that the same way we did with the brass pin that was in the middle. I keep turning the knife over to check and see if the pin is beginning to push through the other side. This steel pivot pin was being especially stubborn, and I was just not able to drive it out. So once I had ground the pin out as far as I could on each side, I pried the knife apart. Now notice that I'm taking care to always pry between the blades and the bolster, the steel parts. If you just slide a tool in between the brass liners and begin prying between them, you'll risk breaking the handles, bending those liners. You'll ruin the knife. Now there's other ways I could have chosen to get that pin out, including drilling it out, cutting the pin in the middle with a knife or another razor blade, but there's risks to any method you use, both to yourself and to the knife, so I try to analyze the individual knife and choose which method I think will work best for this specific situation. But now that I've got it apart, I'm able to remove the blades, cut and drive that pin out from the inside, then take some time to clean these blades and liners.
The problem with our blades is the tang here has worn down. Now, I doubt if I can get the angle just right, but when I'm looking at the blade, I can see by eye there's a little bit of a halo there. You can see this part is worn down. There's a thin layer at the back that has not. So I can get a pretty good idea of how far and in what ways these tangs are worn.
Unfortunately, you cannot see the halo very well in the film, so here's a close-up picture of one from a different knife. You can clearly see how much metal has worn off the tang in this picture. So using calipers, I measure from the center of the hole to the outer edge of the halo in 2 or more places and average those numbers together. It came out to 0.234 inches. I round the number up to 0.235 and use that. Then, after we plug the hole, which I'll demonstrate in a moment, we measure down that distance and mark for the center of our new hole. Now, here's a picture of the smaller blade from the same Ulster knife, which has the identical tang dimensions to our large blade.
The tang on this one doesn't have a halo, but it's worn down much shorter. So I can measure this one with the calipers, see how far it is, and how far it's worn down, and then I'll show you how to repair it. All right. So the first thing I'm going to do, now that I have that number, is I'm going to smooth that halo out. I don't need it anymore. Now, my next job is to move the hole down. How are you going to move a hole? Pretty simple on this. I'll need a nail. Okay, so I have found a nail. This is a piece of one. I've already used it before on a previous knife. So I've checked it with a magnet. It is steel. And I put it into the knife, or into the blade, and I have used a sander to taper the drill. You can see that end, that used to be the head end of it, and I've tapered it slightly. I'll show you in a bit. That's called pin spinning. We spin the pins to get the size we need. But with that tapered, I push it in until it seats firmly. Now I'm going to cut it off both sides. Okay, so I just have the piece of steel in there. Now, it would fall out at this point, probably when we least wanted it to. So we're going to peen each side of it, but we want to do so very, very carefully. If you try to flare that out too much, you peen it, the entire bit of metal will flare, and you'll wind up cracking your blade. I have done that before on a very nice case, unfortunately. So what I'm going to do is just set that on my anvil. You see I make very small taps. I'm angling my hammer going around and around. Now ideally I would flatten the metal first, but I'm not going to bother with it here. You could also use the ball end of the hammer to peen it. That's why it's called a ball peen hammer. You peen pieces of metal like this. Okay, I'll put this side in, move it down, tap it gently, rotating circular motions. Whether you're using the flat side or the ball side, you want to do the same thing. Go around and around this circular rotating motions. Again, we want to swell the ends, the outside ends of it, but also the inside edge of that pin. We want to swell it, but not too much. So you don't want to have very heavy blows, You want very gentle blows. In fact, you're pretty much just letting the hammer fall on it. You lift the hammer, let the weight of it come down. You're not swinging it very hard or putting a lot of effort into it. Okay. Once we do that, we will file these edges completely flat. Now to save time, I'm going to hit it on the sander real quick. Okay. And very important, when you're using a sander on knives, you've got to keep the metal cool. If the metal overheats, you'll destroy the temper of the metal. So I've got a cup of water. I keep that handy, and just a little bit, I will dip the knife in the water to keep it cool. And you'll notice as I'm touching the blade to the sander, I'm keeping my finger on the back side of it. That's to detect how warm it is. If it gets uncomfortable on your finger, the metal is too hot. It's time to dip it in the water again. Okay, we'll see how much of this will show on camera. So there, I've ground it as flat as I can on both sides. You can still see where the nail is, but you don't want to see it very well. Okay. Readjust my camera downward a bit on my workstation. Okay. Now, just to be certain, I'm going to peen it again very, very gently. And the reason I do that is because sometimes these nails will still dislodge because we flared out the ends of it that were on the edge and then ground that part away. But we want to make sure that it's swelled out enough in the center. So that is now one flat piece of metal, essentially. It's not welded, but it is secure. It's not going to fall out. We're not going to have any lateral force pushing on it to dislodge them. Now what we do, .234. So 215, 234. Yep, actually about 2 thousandths. So that's what we're going to aim for. Yes, it's imprecise, but it's close enough for our needs here. This blade was not as badly worn, so we don't need to add too much to it. All right, so I'm going to find my center mark on the line that I scribed and do a center punch. All right, that looks good. I'm not sure how much of that you can see, but my mark is just up from the center. So that's what we're going to drill for now. What size hole are we going to drill? Well, we still have this one. The hole is unworn. We will try different drill bits in it until we find the one that fits it. That one is too large. That one is too small. That one is perfect. You want to drill slowly, and I want to put a little bit of oil, cutting oil, just a drop, to keep that drill bit cool. Okay. Now, before we do much more, I want to deburr that hole. There's a couple of different ways of doing it. I've gotten a bead reamer. This is very inexpensive, just a few dollars off of Amazon. It is diamond coated. It's made for ceramic or bone beads, but I found that it works well for jobs like this. You just want to clean the hole up a little bit. It does taper it slightly, but you want to be careful about that. Let's do a quick test fit of this now. Okay, so we'll put the drill bit through, the knife blade on, move our liner up. I'm not going to put the second blade right now, just this one. Okay, now we will put our springs into place. Here, so we're going to take the tension off the springs to put a pin through. Put it in our vise, tighten it down. And I can look down through the hole and I can see when my springs are lined up. So I just take a bit of brass pin stock. This is used. I've sharpened the end down. And sometimes, if you get it just right, you can drive that in by hand. Sometimes you need to persuade it just a bit. You want to be careful though, since we do have bone handles, we do not want to crack the bone. Rubber protector off that side. So I have the rubber protector on this side. This one will push directly against the spring. Pull it to me just a little. And I could probably angle this vise somewhat so that you can see it. There, maybe you can see what I'm doing a little better now. Perhaps, perhaps not, but we'll try it. Okay, it doesn't have to be tight, it just needs to be in there. Okay, so the knife wants to spread apart on us, we'll gently push it together. Again, this is not a finished product, it's just to see how our blade snaps now. Look at that. Very good, snaps open. It's okay. Now as you see now, we have a problem where the blade does not open up fully. It snaps, but it doesn't open up fully. That's expected. That's because we moved the hole, but the blade, there we go. The blade opens up until the back spring strikes right here at this. So by moving the hole up, we have effectively moved that down. We're going to have to shave about 1.5 thousandths off of that shoulder. We're going to do that very, very carefully. What we do is just do several test fits. I'll probably take it off with a file. You can use a sander, but especially with these sanders, it's very easy to take off too much. So we're going to pull it apart. We'll take that down. We'll continue doing test fits until it fits.
As a brief explanation of what I'm doing here, since I'm moving the pivot hole in the knife to a new position, we must also move the shoulder of the blade to make it fit properly again. So we take a measurement of how far we move that hole, let's call that number X, and then we measure the exact same distance down on the shoulder, make a mark there, and carefully remove that material, working to maintain the original angle.
deal. There we go. And we'll try doing it this way. Again, I don't know how much of that you could see. With my poor lighting in here, probably none of it. But I'm sliding in between the spring. I'm prying up on the spring against the drill bit. And then once I get it up high enough, I'm just squeezing in with my fingers. There we go. There, I like that angle good. We did not take off too much. The snap is good. Now we have effectively shortened the blade. Since we moved that about 25 thousandths, we've shortened the blade about 25 thousandths. You can see that with it sitting in the blade well. It's sitting short, but it was sitting short before because this knife's a used knife. It was well worn. Now I'm going to do the small blade the same way. I'll do it off camera.
Now that I've modified both of these blades, I'm going to do a quick test fit just to check our progress.
Okay, a couple of things here. Typically, most knives, the bolster area here is nickeled silver. So you'll want a nickeled silver pin to go back in its place. This one, however, is steel. So it's a little pitted, has a little bit of rust here and there. So we'll have to put in a steel pin. I found this piece of rusty wire, and it's actually going to be perfect. I'll show you why. We need it to be 79 thousandths. Cut a piece of that off. And this one, according to my caliper, reads in at 96 thousandths. So we just need to take off about 20 thousandths. So I'm going to chuck that up in a drill. And before, when I referred to spinning pins, this is what I'm talking about. We're going to spin this pin down to the size that we need. I'll turn on my belt sander. I've just chucked up in a drill, and I'll work it against the belt until I get it the size that I need. Again, keeping it cool in my cup of water the entire time. Okay, according to the calipers, that's about right. We'll test it in the knife. Yes, goes in. Oh, a little stiff in that one. But it does go in and out. I'll check it on both my blades. There we go. And yes, that should be perfect. Okay. So I've got both the pins spun down to approximately the size I need. We'll go ahead and get started assembling the knife for hopefully the final time. All right, I will start with the steel pen. Now I've got the end sharpened down somewhat. We may have to sharpen it a bit more, especially on the brass one. But you just want it tapered enough that things slide in without too much fuss and trouble. I'll leave both my springs down out of the way for the moment. Okay, just going to drive that in until it stops since we're tapered it. All right, got those in place. Now, for our pivot pin. Let's see. I'm looking through the hole to see when the springs line up. I don't know if you can see that on the camera or not. That looks pretty close. Okay, we're all the way through. Now then. See, I just barely came through. I'll have to drive it in some more. But that, at the moment, should be enough. We'll do another test. Okay, both my blades are seated well. I can get to the nail nick on both of them. The springs are still a little bit sunken in on the little blade especially. That's because of that divot that's worn into the blade. When I have it open, it's sunk in a lot. That's a sign that I did not get my hole centered front to back on the blade. But that is my fault, not the knife's fault. Okay, so we'll get that in here. I'll get my brass pin hammered down a little further. Since it's tapered, we just want to get it in there good and solid. Okay, that's it. It's in place. All right. Now, I cut my pins off a little bit too long. That's just out of habit. I was always afraid of cutting them too short. File down to get rid of those cut marks where it's dimpled in from the cutters. And file a good bit off of that. I just work it down to the length that I need. I believe I'll use my cutler steady because it's a little bit shorter. You might be able to see that angle a little bit better. I'm not sure. Still have my pins a little bit long. You can always file them down. You can't file them longer again. So always a little squeamish about that. Now again, this is my favorite peening hammer. You can use whatever one you want. We'll use the small taps. I will keep angling my hammer around in a circular pattern as I go. And make sure the bottom pin is secure against your anvil. Be very careful not to mushroom it out enough to crack those handles. This one looks like it has a crack that was there, hopefully pre-existing before I started. Very small. Here we go. So I flared it out sufficiently, driven it down. So now I'm going to file that end a bit shorter and peen it. And I want to make sure the bottom side pin is laying firmly against that metal. And you want to be very careful not to crack these antique handles. Get it flared out sufficiently. It's still standing a little bit proud. I'll sand that down. Now, let me start flaring these. I'm not going to peen them very tight yet. Again, peening this one. And you do have to be very careful. If you peen it down too far, you'll put too much pressure, and then the blades won't open. You'll have to fight with them to open or close them. So what I do, I begin mushrooming it out just a little bit. Again, keeping that pattern going in a circle. Round and round. Okay, still got good snap. It's not hard to open or close. I want to see how much wobble I have. See, that blade wiggles too much side to side. This one not quite as much because I've peened it tighter on this side. Now you can put what they call a slackner in there, which is about a 7/1000 inch feeler gauge, and you slide in between the blade, and then you can peen it tighter. I've tried different ones. To me, I just do it by feel now. Which is not as hard as it sounds. As difficult as you'd think. Okay, so we got a little bit of wiggle. That was a little tighter. So just a little at a time.
I apologize for having to mute the audio, but it began raining harder and you just couldn't hear a thing. Right now I'm going to continue the process I've been doing, which is to peen that pin and stop and check the blade snap, the side-to-side movement, the wobble of the blade, until I get those just right. Now, had this been nickel silver, I would have been finished a long time ago. Steel is a harder material. You have to work it more. And as with any of it, though, you want to be careful and not overdo it. So I believe we've just about got it right now. We'll check it a few times, check the snap, the side-to-side movement of the blade. Once we get that right, I'll put a little bit of oil on the blades. Now, this is something you need to do to your knives anyway, those that are in good shape. This prevents this type of wear in the very beginning, and your knives will last much, much longer. Now we're about ready to sand this one down, smooth those pins out, and this knife is very close to being finished.
Now I'm going to continue with the voiceover because of the rain and because of the noise of the sander, but all we're doing here is sanding down the heads of these pins that we put in. Now we do have to be careful. The words Ulster Barlow are engraved into the bolsters. We don't want to lose that. Also, there's a little bit of slight pitting on the surface of the bolsters. I want to keep as much of that as we can while still getting the pins ground smooth. I'm using a 400 grit sandpaper. There is a technique to this, but unfortunately, I did not position the camera so you could see it. So we will try to record that on some other videos, let you see how to sand those from an angle you can see. But we're just going to continually move the bolster against it, keep things moving. We don't want to hold it still and create a flat spot, and we dip it in the water to keep it cool. And we continue this until it's smooth on both sides. All right, guys, there it is. Turned out very well in my opinion. To be picky, the small blade probably should come back just a little bit further, but I think it's good like that. The closing snap is excellent. We'll do this one-handed because I'm having to hold the camera. My tripod doesn't give you a good close-up, but closing snap is excellent. Closing snap on my big blade, or small blade rather, the secondary. Excellent. Opening snap a little bit less. Okay, got it halfway open. As I open it up further, the opening snap is good. My thumb got in the way of it there a little bit, but there it. Good opening snap on the main. Opening snap on the secondary is, see, it's a little mushy on the opening. I didn't get the angle just right on that shoulder. It's dragging. It's still, I can make it snap, but it doesn't naturally have that opening snap. As it's used, it'll probably wear that tip in and get a little better. It's good. It's acceptable. Before, the blade was just mushy. It was, just unusable, really. I carried it for a short while, and it was frustrating. The blade would almost fall open with it in my pocket. The snap was so bad. The tangs were so worn out. But that's how I fix the tang on an old knife where I don't want to replace the blade. I want to keep the knife as original as possible, and that's how I do it.